Now that we have our user ready and also our S3 bucket ready for the state management, we need to initialize our project folder. To do that, open your file explorer, navigate to where you want to create this project. For our case, we are doing it on the desktop. Then create a new folder, give it a name. Our folder will be called Target. You can use any name you want. Open your VS Code editor or any editor you are using. The intention is to open that folder within your code editor so we can start preparing the project files. So to do this, in VS Code or in VS Code, click on this open icon with a folder, and if you don't have this start page, don't worry, you can use the file menu. So on the file menu, you can click on open folder, and on this dialog window, navigate to where you created your folder, and then select the folder, then click on open. Now that we've created our folder, it's time to set up the structure and also start populating our files with the content that we'll be using. We'll have a very simple folder structure. Our modules subfolder here within the root folder. And then we'll also be creating the Terraform files within the root folder that we just created. Start with the main.tf. Then we'll create another file called versions.tf. The other file will be for output. Then data.tf. Need to create the backend.tf. This is where we'll add our backend configuration to save our state. And then lastly, we need to create the locals.tf. These are the main files that we'll be using even across our modules. We'll have a few modules. The first module will be the EKS cluster module. Then the EKS profile module, that's basically the Fargate profiles module. Then we'll have the security group, and then in the main.tf we'll be using the VPC module provided by Terraform on the AWS section. So let's start with the security group. Then we can do the cluster and create another folder for the profile. We'll start with these three. In case along the way you want to add an additional module, we'll create it. You can just copy these files that you already created and then paste in each of these folders. So we'll start with the Fargate cluster, paste in there. Then we'll do the same for the profile. And then we'll do the same for the security group. Now we have our structure in place. Open the backend.tf file. We need to initialize our backend. You can start with the Terraform block, and then on the backend, you can select S3 for the bucket. Remember our bucket name. So this is the bucket name we created and also the one we used in our IAM user setup. Then now we need to enter a key. This is the name our state file will be saved with. So when you open this bucket, the state file will be using this name, the same name as the one we used on our IAM profile. So this is the name we used on our IAM profile to restrict access. Then we need also to specify the region. For my case, I'm using US West 2. Yeah, with that, we are done with setting up the backend. The next thing is to prepare our versions. Here we are adding the provider and also the Terraform minimum version. So we'll start with the Terraform block, and then we'll enter the required version for our Terraform. At this time, we are using version greater than or equals to 1.3. Then we have a few providers. We'll start with the AWS provider. So for the AWS provider, we'll be using version 5.34. This is the latest. The day I was recording this, you might find a more recent version. We'll also need Kubernetes version 2.25.2. And lastly, we'll need the Helm provider also. It will be version 2.12.1. Then we need to add our providers. The first provider will be our default provider. This one will rely on the region variable. We'll create the variables next. And then since it will be our default profile, we don't assign an alias to it. Actually, I just remembered we don't need the Helm provider. Then we'll just initialize the Kubernetes provider. We'll just be using the local kubeconfig. So we just enter the default kubeconfig path. If you intend on using a custom kubeconfig path, you can enter that path here. So for this one, we'll populate it once we have created the infrastructure and also deployed the Kubernetes cluster. So we are done with the versions and also the providers. The next thing is to pass in our variables. You can see I forgot to create the variables file. So make sure you create the variables.tf file. And the first variable will be a string for region. Give it a quick description. Give it a default of. You can use your own given region here. Second variable will be for name. This also will be a string, and this will be the project name. So we can add a section at the top here to just demarcate this as the common variables that are shared. We need to create the VPC variables. The VPC variables will specify the VPC CIDR block, which will be a single string. Use the short form, and then you can give it a description of your own. Give it a default value, 172.16.0.0/16. The second VPC variable will be the private subnets followed by the public subnets. So for the private subnets, we'll use this name. You can start with the public subnets depending on your preference. And then for this setup, we'll only be using 2 pairs of subnets. Depending on your use case, you can use more. You can reference the VPC documentation to learn more about the subnet allocation. The private subnets, it will be a list of strings, which will be 2, and then they'll be using 18. You can just copy the same, paste it there, and then from 0 we are going to 64. You can copy the same block and then use it to create public subnets. Make sure you update the description, and then from 64 we are moving to 128. Make sure this order is maintained, and then from 128 you're moving to 192. So there is a requirement for an EKS cluster. You need at least 2 availability zones, and for the VPC module to be able to create 2 availability zones, you need to specify at least 2 subnets. That's what we are doing. So we have 2 pairs of private subnets and 2 pairs of public subnets. We need tags for our subnets. These tags are required by the cluster, and also just to make our names unique, we'll be starting each name with the VPC. The tags will start with the VPC private subnet tags. Then we can assign them a default value. This will be a map of strings, and for a map, it's an object that has key value pairs. The private subnets will be using this tag, and then we can copy the same block and create another variable for public subnet tags. Create another key value pair. The value will be 1, and then the key will be kubernetes.io/role/elb. That's it for the VPC variables. Next, we need the EKS cluster variables. And for that, start with the EKS cluster unique ID. So this is just the unique ID for the module in case you're creating multiple modules. This one will be a string, and the default value will use a cluster. The second variable will be the default IAM path, so we'll name it KS. It will also be a string. Default value for this will be /root. That variable will be the EKS KMS deletion window in this. This will be a number. So by default, setting this to 30. The next variable will be whether to enable EKS cluster encryption. This will be a boolean. Default will be false. Then we need to create the cluster version variable. So it will be EKS cluster version. This one will indicate default. For now, we are using version 1.29, which is one of the currently supported versions on EKS. Next variable will be used to configure Terraform resource timeouts. This will be used in the cluster resources, and it will be named EKS cluster timeouts, which will be a map of 3 strings or of 3 items, namely create, delete, and update. Next will be the EKS data plane wait duration, which is the duration to wait. After cluster creation, before creating the data plane components, the default value will be 40 seconds. You can use 30 seconds. And now we have the cluster add-on timeouts. These ones will be the same as these ones. So let's just copy that, rename it to add-ons. This should be plural. Then we can specify the enabled log types for the cluster under a variable named EKS enabled cluster log types, which will be a list of strings. So the default value will contain the API. We'll also enable audit. You can minimize this depending on your needs. We also include authenticator. Also have controller manager. We have scheduler. We'll add another variable, EKS create log group, which will be a boolean, and it will indicate whether we are creating EKS CloudWatch log group within our cluster module. And the default value for this will pass in true. And we have another variable which will specify the retention days for our CloudWatch log group. So it will be named EKS CloudWatch log group retention in days. Give it a description. This is the number of days to retain the log group before it gets deleted. This variable will be of type number, and by default will specify 90 days. Lastly, we have an optional variable for EKS CloudWatch log group KMS ID. By default is a string. So we are done with the variables. The next step is to create our locals. Locals helps you transform your variables in a format that will be usable in your application. We are starting with the common local variables, and here we'll be specifying a locals block. Within the block, we'll specify the common tags for the application, and in here, the first tag is project, which will use our var.name variable. The second tag will be Terraform, which will be a boolean of true. So those are our common tags, and then we'll have a shared ingress rule for our security groups in case we have multiple in place. The ingress rule will be a map with the following keys: CRDR blocks. So this will allow traffic to anywhere. Description, we can just call it egress. Then from port will be 0. The PV6 block will be null. Then we have prefix is this as null. We are not specifying that value. And then for the protocol, we are using -1. And then for the security groups, we are passing in null. For the 2 ports, passing in 0. And then whether this rule applies to self, we are not specifying that, so we'll pass in null. Once we've created the common local vars, we'll create the target security group rules. We can create a new locals block. The first variable should be an array of maps. Then you can just copy these keys up here from the previous object, add them down here. For this rule, you can just say ingress EKS. For the CIDR block, specifying null. The from port, we'll leave it as 0. Then for the rest, we'll leave them as null, and for the protocol and the 2 port, we'll use 0. Then for self, we have to specify true, so that this rule can also apply to the security group itself. So initialize another locals block, and then we need to create our profiles, which will be an object of objects, so it will be a map of maps. The first profile will be cube system. Since we are using Fargate, our node groups will be called Fargate profiles, and for a Fargate profile, it needs the following components. So for the selectors, you have to pass in an array. So you have to specify under selectors the namespace that will be selected for this profile. Our namespace will be cube system. This up here is just the name of this particular map, but now the effective values are within this object's name. So we'll specify the selectors namespace here, and then we'll add labels. These are labels that are used by Fargate to select pods that are allowed within a given Fargate profile. For the labels for the cube system, we'll leave them as blank so that we can select as many pods as possible that are supposed to run in the cube system namespace. You can restrict this and create multiple profiles for that, but for this case, you're just leaving the labels as empty. Then we'll add subnet IDs. These ones will come from the VPC module that we'll create in a bit. So we'll have module.vpc.private subnets. You can use the variable, but I prefer using the resource itself. Then we can supply a unique ID used as the name for this profile. That will be cube system. Then we have the timeouts. This will be used for the Terraform lifecycle. So for creation, we'll be giving it a timeout of 20 minutes. It should be a string. For minutes, make sure you use an M. And then for delete, we'll also use 20 minutes. Then we specify whether we'll create an IAM role, and the answer here will be yes, true. We'll also be indicating if you'll be attaching a CNI policy, and then you can pass in additional policies. We are not passing in anything, so we'll pass in an empty map. Then we'll be specifying whether we are passing in a pod execution, assume role ARN, and then we can pass in the tags. Since we won't be creating EC2 instances for our resources on Kubernetes, you have to create another profile for core DNS pods. For that, we'll just copy the first profile we just typed and then add it down here. We'll change the name to core DNS. Up here, we forgot something. We needed to add a name for our profile, which will be cube system. Then down here, the name will use coordinates like that. Make sure you use the same casing. Then the namespace will be cube system. Then it will be using a specific label to select the coordinates pods. For the subnet IDs, we'll be using private subnets. And then for the unique ID, we'll be using the name. We'll be sharing the timeouts, and the rest of these can also remain the same. So we'll just copy this coordinates and create another profile that we'll be using for our applications now. This one will be named apps. This way we'll be installing our apps, and the selectors, we have multiple selectors. So we'll just start with the default namespace, and then the label will be using profile apps. Now the beauty with using Fargate, you can create multiple profiles and then designate them using different namespaces and also using different labels. So you can get creative with this. You can create profiles for dev, staging and production environments, or even profiles for different apps so that they can be deployed in separate profiles. So that's the first selector. We'll specify the second selector for the default namespace still. Since this is a list, you have to separate the items with a comma. So for the second one, it will use a hyphen and a wildcard to select any labels that will be using a prefix of this apps hyphen and then followed by any other string. We have a third one which will be apps without a wildcard, and then we'll have another one which will be using a prefix both for the namespace and also a wildcard for the label. This one will match any namespace that starts with these characters, and this one will also match any pods deployed in this namespace that have this label profile and with a value that starts with this prefix. So this is one way of doing it. You can get creative with this and then design your cluster setup in a given way that suits your organization needs. For the subnet IDs, we are using the private subnets. Then for the unique ID here, we need to use the correct name it apps. For the role, we are creating it, and then for the rest, leave them as default. We need also to add the cluster add-ons. We'll add them in a separate block. So you can add as many add-ons as you need, but we need these few add-ons for this case. We need the kubeproxy add-on with no custom configuration. Then we need the VPC CNI. If you'll be using EKS pod identity, you can add that add-on here, although we won't be using this one in this tutorial. Then lastly, we need to add another important add-on, CodeDNS, and then CodeDNS will take a custom configuration. We'll specify the configuration values, then JSON encode them within an object, which will take only one value, which will be a string. This is case sensitive. And with that, we can close the local variables creation.